continue on with our properties of quadrilaterals here, right? Remember that we did last week, we did the quadrilaterals and the parallelograms, and our next one we're going to do, and you can just put this right on here, right? Put a line across, and we're going to do next is we're going to do rhombuses next. Okay. The definition of a rhombus, in case you didn't remember or don't remember from years past, is that all four sides are congruent. Okay. Okay, so that's what makes a rhombus, right? That all four sides are congruent. Okay, so let's take a look at some of the properties here, right? So here we have a rhombus, right, that I built, and if we actually go and measure the sides, you'll see, boom, there we have, right, that they're all 5.8 there, right? So it truly is a rhombus, no matter how I move it around. Okay, all right. One of the things that would be helpful to know is, yeah, we know that a rhombus is a quadrilateral, but is it also a parallelogram? And all right, we could figure out that by, well, we could just figure out if these opposite sides are parallel. And they definitely look like they are. We could check by just measuring some angles here. If I measure this angle right here, right? Okay, I get 81.15, and I measure this angle right here, I get 98.5. If I add those two add up to 180. Remember that if you have same side interior angles that add up to 180, then lines are always parallel. That's from back when we did parallel lines unit, not even just the parallelogram stuff, right? If I drag it around and move it around there, right, no matter how I move that, although this one's not changing, let's see if I can get it to change. Okay. Right. No matter what I do, right, those two add up to, these two same side interior angles add up to 180. So it's definitely a parallelogram. So if I go back to my properties here, right, I can say that a rhombus is a parallelogram. Parallelogram. So it has all properties of a parallelogram. So it has all parallelogram properties. Okay, so we can see that there's a whole list of them, that we'd have, like opposite sides are congruent, diagonals are not congruent, but they do bisect each other, diagonals form two congruent triangles, consecutive angles are supplementary, lots of things that we had from before. So all of these properties from before, because it's a parallelogram, still apply. Okay, so, and now let's go look at what else we know, right? Okay. Oh, and the other one, opposite angles congruent for ourselves. That was a big one for ourselves. Okay, so we have a whole bunch of things we can just put in there. Now, if we were to actually construct the diagonals, right, for ourselves of this, okay, we can again, like we just said, they're definitely not congruent if you look at it. But if I were to construct those two diagonals, put a point right here, okay, and then measure the angle that I'd have right here. Okay, so that's what I'm going to go and do. So measure that angle. So you can see that it's a right angle, and I can measure all the other ones, but they're also going to be right angles, right? Because vertical angles are congruent, and then these two add up to 180. Okay, so if I drag it around, is it always going to be true? Yeah, it does. Okay, so let's go and we'll add that as a property for ourselves. Right here is that diagonals are perpendicular bisectors. Now, I'm adding in, I didn't prove they were bisectors just there, but if we think back to what we knew about parallelogram, we knew that the diagonals bisect each other, and here we found that they're also perpendicular. So we have that added piece. Okay, so what's really going to be helpful as we do these examples is that you notice that because this is a right angle here, we have a whole bunch of right triangles. Okay, so we can also write down the diagonals form 4 right triangles. Okay, so we're going to be using Pythagorean theorem here for ourselves. Okay. Okay. The other important thing that we have with these is that if we were going to actually measure the angles right here, right, these angles, right, the angle between this, got the wrong thing. Let me go, sorry, measure. There we go, angle. So we have this angle right here and this angle right here. Oops, I don't know if you can see those numbers there. Right, but if we measure those two angles, we can see that they're both 41.4. Right, so as we look at this, if I drag things around there, right, we can see that those angles, actually that one's not even changing because of how I built this, it's not changing. There we go, now it's changing, okay? And you can see that no matter where I put these two sides these two angles are congruent, okay? So we look at it, right? We can see that this diagonal is bisecting this angle, right? If we also went and measured the other angle, right, down there, okay. I don't know how well you can see it in there, but they both came out to be the same measurement as well, right? That those were congruent. And if I drag this forward and back, you can see that both angles are bisected by the diagonals. So we'll go to our chart here and add that in. Diagonals bisect the rhombus angles. Okay, so we have our properties. Okay, so let's do some examples of rhombuses then, now that we have that. Okay. So, example 1, find the measure of the remaining sides and angles for each rhombus. Okay. So, hey, a rhombus is a parallelogram, so I know that opposite angles are congruent. And I know that all 4 sides are congruent because it's a rhombus. If these are each 100, that means that each of these are 80. So some of these are super, super quick, right, for ourselves, just because we know the properties. And if you don't remember those properties, that's why you have this chart right here, right? This chart's going to help you, okay? So you would do the same exact thing to find this one, right? Consider that a rhombus is a parallelogram. So, after you mark all 4 sides, then you say, okay, opposite angles are congruent. You put that on there. Consecutive angles add up to 180. Right, so you'd be all done. Okay, so those ones are pretty quick and simple. These ones are going to take a little bit more work. Find as many missing measures as possible for each rhombus. Okay, so rhombus, all 4 sides congruent. I'll put the 7 in for everything. Okay, the next thing I typically do is I put my right angles in here, because remember that the diagonals are perpendicular bisectors of each other. So okay, so it's perpendicular, and then, oh, that's 4 as well. I can't say each of these are 4, because remember the diagonals aren't congruent, they just cut each other in half. So I know that they're congruent, so I'll put tick marks in each of those. Okay. Okay. Hey, wait, I have a right triangle right here. Okay, so that's a 90-degree angle, that's 32. If I subtract it from 180, okay, I got 60, I get, sorry, 60 or 50, 58 degrees, 58 degrees, okay. Okay. All right, so I'm using this right triangle right in here to get that. Okay. Okay. And once I have that right triangle, right, that's great, right, we can remember that all 4 are right triangles. We can remember that the diagonals bisect the angles. That's probably the easiest way, so I'll put those 2. Okay. Opposite angles are congruent, right? So these are congruent. Hey, well, then if you're cut in half, then those are also going to be congruent. Right. Another way to think of that is, hey, look at all these 4 triangles are congruent here. So if you just finished one triangle, you can just kind of, flip it over to give you the other side, and then flip it over to give you this one, and so you can just kind of repeat those triangles all around, okay? So that's how we do that one. If you, for example, 2 here, right, okay, so 10 for everything. Oh, I forgot to do one measurement up here. Whoops, whoops, whoops. Okay, I forgot to find this measurement in my right triangle. Since I know it's a right triangle, I can use Pythagorean theorem to get this. So 7 squared equals 4 squared plus, we'll call that b squared. Okay? So, all right. So we're going to use Pythag because we have right triangles. Okay, so this one, we can do a little bit more with it. So 49 equals 16 plus b squared. So b squared is 33. We take the square root of it, and we get the not too pleasant square root of 33. It doesn't reduce, so we just leave it there. Okay, and that's okay if it doesn't reduce. Sometimes they do, sometimes they don't. If we're doing this one, right? Okay, we did all four sides congruent. Diagonals bisect each other, so I'll put a 6 there. I remember that these are all right angles, right? So I have a right triangle right here. Let me highlight that right triangle for myself. I could have highlighted any of the right triangles. Let me highlight this right triangle right here. Okay. I could do Pythagorean theorem. I could hope it's a triple. Let's see. Oh, it's a triple. So that's 8. So that's 8. That's 8 because the diagonals bisect each other. Okay, so I did all the side lengths first. That's why they're done. Okay, so that's a really great strategy to use. Just get the lengths done so then you can go to the angles. For the angles, I remember that diagonals bisect, right? Diagonals bisect the angles, so this is going to be 36 here. Okay. Opposite angles are congruent, so that's 36. Okay. I have a right triangle right here. I know that the angles sum to 180, so I could do 180 minus 90 minus 36 and get 54 degrees. Okay, so I have my rhombus completely solved, right? And that's how we do rhombuses. So